Hi friends, today our topic is waves. When I say hello, some work is going to be done in your ear, right? That means your eardrums gets vibrated. Who are causing for this work done? Yes, that is energy. When I say hello, some amount of energy which I spent that is reaching you, right? How this energy traveling from my side to your side? Yes, in the form of waves. That means in the form of traveling wave. Our intention in this video is finding wave equation for traveling wave. For analyzing these waves, we have so many graphs, that means waveforms available. For example, rectangular wave. This is amplitude, this is t. Time period is tau. If we consider rectangular wave at time period, time t is equal to tau by 2, half of the time period, the amplitude changes from minus a to plus a to minus a within no time. That means time interval is 0, but amplitude changing from positive a to negative a. In physical quantities, this is impossible. If the quantity having mass, within no time there is no sudden change, right? So this graph is not possible for analyzing traveling wave. Another wave is triangular wave. Here also at time period t is equal to tau by 2, here is also direction suddenly changes. Another wave is sine wave. This is suitable for analyzing our traveling wave. And right, we have examples of traveling waves are sound waves, electromagnetic waves means a light wave, and wave in the stretched string. That means pulse traveling from my side to other side in the stretched string, right? For uh, modeling of mathematical modeling of a wave, you simply take one example, that is particle rotating in a circular path. Let particle starts here, let t is equal to 0. For completing one cycle, time period is tau. If we draw the graph between amplitude, that means projection of this particle displacement on y-axis with respect to time, we get sine wave, right? At t is equal to 0, y is equal to 0. At t is equal to tau by 4, y is equal to a, maximum amplitude. At in t is equal to t by 2, tau by 2, y is equal to 0. T is equal to 3 tau by 2, tau by 4, y is equal to again minus a. T is equal to tau, y is equal to again 0. If we draw the graph between amplitude versus time, we will get this sine wave, right? The time, this length is lambda, right? This is wavelength, length of the wave, and time taking for completing one circle is tau. This is time period. Is this wave is traveling wave? Y is equal to a sin omega t. Is this is a traveling wave? No. This particle, projection of the particle moving, oscillating on the y-axis, right? But this particle is not moving. In horizontal displacement is 0. Horizontal displacement is 0, right? So V is equal to 0. Here particle velocity, wave velocity is equal to 0. But wave is oscillating, right? But our intention is to find the equation for the traveling wave. So we will introduce extra variable, that is displacement, in this equation, right? If one person is traveling or moving, we should mention position of that particle. అంటే ఒక పర్సన్ మూవ్ అవుతున్నాడంటే అతని పొజిషన్ చేంజ్ అవుద్ది. సో మనం ఒక ఎక్స్ట్రా వేరియబుల్ని ఇందులో ఇన్సర్ట్ చేయాలి, దట్ ఈస్ ఎక్స్, డిస్ప్లేస్మెంట్. How we will introduce that variable in that function, right? To understanding to introduce variable in this function, this wave is at y is equal to sin omega t. This is y is equal to a sin omega t. At t is equal to 0, right? This is y of t minus tau, t naught. The wave is delayed by t naught seconds, right? And at t is equal to 0, the waveform is here. ఈ వేవ్ ఫామ్ ని t naught టైం డిలే చేస్తే, అంటే let t naught is equal to 4 seconds. This is 4 seconds. t naught 4 seconds అంటే waveform starts at 4 seconds. Another wave y of t minus 6 seconds. Let's say here waveform starts at 6 seconds. అంటే 6 seconds డిలే చేసాం వేవ్ని. ఇప్పుడు ఈ వేవ్ ట్రావెల్ అవుతుంది అంటే మనము ఫాస్ట్గా ఈ వేవ్ ఫామ్స్ అన్నిటినీ ఒకదాని తర్వాత ఒకటి చూస్తే మనకి ఈ వేవ్ ఫామ్ ట్రావెల్ అయినట్టు అనిపిస్తుంది. అంటే అలా మనకి అజ్యూమ్ అవుతుంది. సో వీఆర్ delaying the waveform and watching this wave in sequence here. Then we will feel that this waveform is traveling, right? For right shift, అంటే పాజిటివ్ డైరెక్షన్లో షిఫ్ట్ అవ్వాలంటే మైనస్ తీసుకోవాలి, అప్పుడే డిలే అవుతుంది. వేవ్ఫామ్ అనేది డిలే అవ్వాలంటే ఇక్కడ నెగిటివ్ తీసుకోండి. ఇఫ్ we take positive, the waveform is advanced. That means negative direction, right? Here y is equal to a sin omega t minus t naught. t naught seconds ని డిలే చేసానంటే waveform, now waveform is starting at t naught. Distance traveled in t naught seconds is x, right? velocity of the wave traveling, that means this v, right? Velocity of the wave is v. Then time t naught is equal to distance by velocity. Duramu by vacuum is equal to calm, right? So y is equal to a sin omega t minus x by v, right? Here this is position time graph, right? Here this is time. Omega is equal to 2 pi by tau, angular frequency. If we take position displacement graph, this length is 2 pi, this length is lambda. So new variable k is equal to 2 pi by lambda. This is angular wave number. Here 2 pi by t is number of cycles passing per second, that is frequency, right? Number of cycles traveled within 1 second, right? That is angular frequency. Here number of waves traveled per unit length, that means for traveling of this particle, for ఈ పార్టికల్ లాంబ్డా డిస్టెన్స్ ట్రావెల్ చేసేటప్పుడు ఎన్ని సైకిల్స్ని కంప్లీట్ చేసింది, ఆ ఇన్ఫర్మేషన్ అనేది కే ఇస్తుంది అనమాట. కే దట్ ఈస్ యాంగులర్ వేవ్ నెంబర్, రైట్? హియర్ y is equal to a sin omega t minus omega x by v, right? Omega x by v. Omega is equal to 2 pi by time period. Velocity is equal to, here observe, this is lambda, this is wavelength. For passing this wave, time is tau, right? Velocity is equal to distance by time. For traveling lambda distance, it takes tau, time period. So here omega by v is equal to 2 pi by tau by lambda by t. Tau gets cancelled, that is 2 pi by lambda. So our k is 2 pi by lambda. So here we can write a sin omega t minus kx. This is our wave equation, right? This is our wave equation. Here observe, v is equal to, velocity is equal to distance lambda by time period, time tau. This is 1 by tau is equal to frequency. Velocity is equal to lambda into frequency. 1 by tau is equal to frequency, right? 1 by time period is frequency. Here this is velocity of the wave, not velocity of the particle, right? This is horizontal velocity. How can we change the velocity of the wave? by changing frequency, but by changing lambda. But this frequency is in the hands of creator, right? Who are the creator of the wave? If I vibrating stretched string, I am the creator of waves in the stretched string. How fast I am oscillating that stretched string, then that frequency depends upon my shaking of the string, right? This lambda depends upon medium, right? If wave is traveling in air, the properties of air, uh, lambda depends on property of air, but frequency depend on creator of that sound, right? This is a wave equation, right? Next, our topic is wave in a stretched string. That means one end of the string is fixed end. When I vibrate the string at one side, the wave is generating here and traveling towards the fixed end, right? With velocity v. Now, shape of this wave is looks like bell. If we draw a graph between amplitude for this function y is equal to a sine minus x square, we will get the graph looks like this. That means bell function, right? This is bell function. That means for every value of negative value or positive value of x, y is always positive. E function gives like this. This is e function. E power x square gives decreasing order, right? This is y. So for calculating the wave, traveling wave in a stretched string, this e power minus x square is useful for finding wave in the stretched string. But this is not a traveling wave. We know for getting traveling wave there is two variables. That is, one is time variable and second is displacement variable, right? So here y is equal to a amplitude into e power minus t by tau minus x by lambda square. This is the waveform of the stretched string, right? Observe here, there is no 2 pi term here because this wave is not oscillating, right? So there is no 2 pi term here, t by tau minus x by lambda, right? Next, our topic is velocity of the particle. Velocity of the particle, right? Till now we discussed velocity of the wave, but now velocity of the particle, y is equal to a sin omega t minus kx. This is our waveform. If we derivative with respect to time, dy by dt is equal to a omega minus cos omega t minus kx. This is the velocity of the particle in y direction. That means where is the particle is oscillating about its mean position, right? But energy is traveling in x direction, right? but the velocity of the particle in x direction is 0. That means if we traveling wave in a stretched string లో పార్టికల్ అనేది మూవ్ అవుతుంది, ఓన్లీ ఎనర్జీ అనేది ఇక్కడ నుంచి మూవ్ అవుతుంది. సో వెలాసిటీ ఆఫ్ ద పార్టికల్ ఈజ్ a omega into cos omega t minus kx, right? This is the velocity of the particle. Next our topic is energy of the wave, traveling wave, energy of the traveling wave. Energy of a traveling. Energy is equal to kinetic energy plus potential energy, right? Kinetic energy is half mv square, right? Let us consider one particle. The particle is moving upward and downward. I consider one particle. So of kinetic energy is equal to half mv square per particle, right? Of m into v is equal to a omega cos omega t minus kx. This is v, right? Whole square means this is kinetic energy. Potential energy of the wave is here. This wave is elastic nature, so potential energy in the elastic medium is of kx square. This k and the wave number is different. This k we getting from force in the elastic medium is minus kx, right? A is equal to minus k by m into x. This is a proportional, a is equal to omega square into x, right? Omega is equal to k by m under root. This is the k, spring constant, like that. So here is equal to half k is equal to omega square into m, right? Here k is equal to omega square into m into x means vertical displacement. The particle is displaced in vertical direction, so y square. So here half omega square in m into a square sin square omega t minus kx, right? This is potential energy. Total energy P plus K is equal to total energy sin square cos square. Sin square plus cos square equal to 1, right? Is equal to half m into a square omega square. This is the energy of the particle, single particle, right? For energy density means energy by volume, right? Energy density. Energy density is equal to half m v square a square by v. For single particle, energy density is equal to m by v is equal to rho. Energy density. Of rho omega square a square. This is the energy density of the wave, right? Next our topic is power. Power of this wave. Power of traveling wave. Power is equal to energy by time, right? The energy is equal to of m a square omega square, right? By time. The wave is traveling like this. The area of cross section is S. The distance traveled is let's say distance traveled is x, right? Yes, volume of the medium traveling wave is cross section into displacement traveled, that is delta x. So here mass is equal to volume into density a square omega square by t. Here V is equal to S into delta x of V is equal to S into delta x rho a square omega square by t, that is delta t. Delta x by delta t, horizontal displacement by time is equal to wave velocity, right? This is of aerial cross section into wave velocity rho a square omega square. This is the power of the traveling wave, right? Now intensity. Intensity means power traveling per unit aerial cross section is called intensity. That means power is traveling per unit aerial cross section, that is called intensity, right? Power by aerial cross section. So intensity is equal to SS get cancelled of V velocity into density into a square omega square. ప్రీవియస్గా చాలా క్వశ్చన్స్ అనేవి ఈ పవర్ ఇంటెన్సిటీ మీద ఇచ్చారు. ఇంటెన్సిటీ ప్రపోర్షనల్ టు ఏ స్క్వేర్, రైట్? పవర్ ఈజ్ ప్రపోర్షనల్ టు ఏ స్క్వేర్. So many problems we are getting from power and intensity. So in next video మనం సూపర్ పొజిషన్ ఆఫ్ ద వేవ్స్ గురించి తెలుసుకుందాం. థ్యాంక్ యూ.